Hello. So today we are going to be looking at some problems and some tips for the UK Junior Maths Challenge, which is coming up pretty soon. So one of the first things we need to talk about is a couple of methods for saving time. If you can save as much time as possible, then you have more time to deal with the harder problems, and thus your chance of getting a higher score is increased. So let's talk about problems where you need to save time. So let's go for a really basic one. Let's say that I tell you that there's a rectangle and that the dimensions of it are 3x plus 6 and 9x minus 2. Now let's imagine I told you that the perimeter of this shape was, I don't know, 100. So the perimeter was 100. So the perimeter was 100. And you've got to try and find the length of each side. You just got to be very, very quick with the execution here. So you could write it out just like this. We're going to do 3x plus 6, 3x plus 6. You can do this mentally. You don't have to do this on paper. 9x plus 2, minus 2. Then you're going to add up all the x's together. 3, 3, 9, 9. What's that going to be? 9 and 9, 18, add 6 is 24. 24x. We've got 6, add 6, take away 2, add 2. That's going to be plus 8. Now, we've done that. 24x plus 8 equals 100. Take 8 from both sides. 92. Okay, now we've got to simplify this. Easiest thing to do is just to write it as a fraction and simplify it. 92 divided by 24, which can be simplified because they're both even. It makes 46 over 12. 46 over 12, which equals 23 over 6. And then it can't be simplified any further. 23 is a prime number. That's the sort of speed you need to be able to go at. Ideally, you can do the adding up mentally. But this idea of getting all the x's together, all the constants together, if you've got x's and y's, you do all the x's together, you do all the y's together. That kind of choppy, quick thinking will really save you time collecting the like terms, because that's something that comes up multiple times. Yeah. One of the next things that we need to talk about is problems where you don't have to do as much calculation as you think. So imagine I gave you a cube and I said you have to work out the surface area of this cube. Okay. And I tell you that the length of each of the sides is 1.2. Now you might think, okay, that's quite an involved calculation with quite a few steps, but remember the math challenge is multiple choice. So let's say these were the options. That's an 8.64. Well, it turns out that actually you don't have to do as much calculation as you thought. The first thing to realize is that you've got to do the 6 faces, and each one of them is going to be a 1.2 by 1.2 square. So the area of them is going to be bigger than 1. So there's no way it can be 5. 5 is just too small. Okay, so we've already eliminated 1. Now, okay, you actually have to do the calculation, but this is going to be 1.44. So now you realize that's going to be multiplied by 6. That's just not going to give you a whole number. So you can get rid of 10. Now, let's look at the last digit. If you're going to multiply this thing by 6, 4 times 6, it's going to be 4. So the last digit is going to be 4. There you go. Done. You don't have to do as much work as you think. Okay. Now, let's go for another problem. Now, only one of these numbers that I'm going to draw here is divisible by 12, and you have to work out which one it is. So we've got 12,000, let me write this number out first. What is this number? 1,212,321. Okay, 12, 3, 1, 2, 1, 2. 12, 3, 1, 1, 2, 2, and then 12, 2, 1, 2, 3, 2. So only one of these is divisible by 12. What you are not supposed to do is try to do your like short division or long division, whatever, and try and divide them. There is a quicker way, and you can do this by inspecting the digits. So please pause the video, try to work it out without doing a full division. Okay, welcome back. So the first thing we can do is we can realize this one ends in a 1. There's an odd number, so it cannot be divisible by 12. Now let's have a look at maybe this one. What happens if you notice they all start with 12, so that's actually a bit misleading. So we just need to work out which one of these is divisible by 12, because we know that 1,200,000 is already divisible by 12. So now we've simplified the problem. Okay, well let's have a look at this. 2, 1, 2, 3, 2. If you add these up, you get 10. Now you should know that all multiples of 3 are their digits add up to a multiple of 3. 10 is not a multiple of 3, therefore this cannot be in the 3 times table. If it's not in the 3 times table, it can't be in the 12 times table. Now we've got 2 to choose from. Which one would be easier? Well, this one here has already got a bunch of 12s in it, so we know that 1212 is divisible by 12. So now the question is just, is 300,000 divisible by 12? Well, 12 goes into 60 and 60 goes into 300, and this is just 300. Therefore, this one. So what was the number? It was 12. Sorry. There we go. So we know it was the second option. You don't have to do as much work as you think. Now, let's talk about simultaneous equations. These turn up a lot. Simultaneous equations are just when you have more than one equation with more than one variable. In general, they're very, very difficult, but the ones they give you in the UK Maths Challenge are usually quite simple in the sense that their answers are usually, like 2, 3. You might get like a half. I think it's unlikely that you'll get a negative. Usually they have quite simple, usually positive integer solutions. So we're going to look at a classic, which you can already find analysed in many parts of YouTube. But this is a great example of a simultaneous equation that when it's written properly becomes much clearer. So the idea is you've got a cat. It's a very, very thin table. There we go. So we've got a cat on a table. This is my bad picture of a cat. And there's a tortoise beneath it. And the difference between the head of the tortoise and the top of the head of the cat, we are told, is 170. Now we're told that you pick up the cat and you put down the tortoise on the table. So we've got the cat, and then we've got the tortoise here. You can see I'm not an artist. And now we're told that the difference between their heads here is 130, which kind of makes sense, right? Like the tortoise is supposed to be a bit smaller than the cat. But then what they do is they ask you, what's the height of the table? Now this seems a bit strange because there's 3 things we don't know. We don't know the tortoise, we don't know the cat, and we don't know the table. So this seems like we're given just 2 situations but asked to find out 3 things. It should be impossible. But when you write it down in a right way, it all becomes clear. So please try to find as much practice of these kind of problems. So what we know is that we know the cat plus the table plus the tortoise. I'm just going to call it E. Okay. Sorry, minus the tortoise, that was the first case. Minus the tortoise was 170. Now what we know is that the tortoise plus the table minus the cat, you see I write it this way, equals 130. Now can you see I've got positive C, negative E, positive E. If I were to add these up, it'd be very simple. They would just cancel, that's 0. T add T is 2T. It's nothing. 300. Therefore, the table is 150 centimeters, I guess. You still cannot work out the cat. You still cannot work out the tortoise. But that doesn't stop you from working out one of the variables. This becomes very, very clear when you write it this way. If you're trying to think about it as a diagram, there is an interesting visual way to think about it, but I wouldn't say it's particularly clear and involves drawing them stacked on top of each other. So please get used to phrasing things in this way and look for things that will cancel. Look for positive and negative versions of the same variable and see if they cancel. This will really help you with simultaneous equations. Okay, and I just want to leave you with some exercises that should help you with a kind of problem that came up last year. So last year for question 25, which I think was pretty challenging, they had this question, what was it? They had this question that involved like a stack of numbers, and the idea was that each new row was produced by adding the things in the row below, like a kind of inverted Pascal's triangle. So for example, if this was 3 and this was 6, this would be 9. If this was 1, this would be 4, this would be 13, blah, blah, blah. That's how it works, right? These two add up to make that. So you can practice on these. I don't think a very similar problem will come up, just like they did last year. They're not that predictable, but it's good practice anyway. So my first problem for you is to try to understand this thing as a whole. You need to be able to answer the question, if this is odd, if the last number at the top is odd, what do you know about the numbers here? Okay. Now, of course, you can't know what they are because you don't know what this is, but you can know something about them. Okay, and I'll give you a little bit of a hint. If this is odd and this is odd, then this must be even. So you might be able to work out this one can't be even and this one can't be even. Think about that, okay? I'm not going to post the answer here, but it's just a good way for you to understand how knowing something up here can give you information down here. That's the first thing. Now the next problem I think is quite a lot of fun. The idea is I'm going to give you the numbers 5, 7, 6, 3, and 1. And I want you to arrange them in the bottom row. I don't know, like this, for example. You could do it like this. And I want you to arrange them so that the number at the top becomes as big as possible, and then I want you to find the arrangement that makes them as small as possible. This will really help you understand how these pyramids work as a whole. So let's just try this one. So 7 add 1 would be 8, 1 add 6 would be 7, 6 add 3 would be 9, 3 add 5 would be 8, 9 add 8 is 17, 7 add 9 is 16, 8 add 7 is 15, 15 add 16 is 31, 16 add 17 is 33. Add these together, you get 64. Now I want you to find the arrangement that makes this top number as big as possible, and then do it as small as possible. This one's quite fun because you feel that it shouldn't matter which order you do them in, right? Because, you know, like 6 plus 3 is the same as 3 plus 6. And you're saying, oh, well, Alex, okay, I add all these things up. It shouldn't matter. They all work out in the end. Well, you're wrong if you're thinking that. And you need to find out why. Yeah, I really like this problem because although it's made out of very, very straightforward elements, gets you thinking about systems as a whole, not just the elements. How do all the elements come together? I hope you find that useful. Leave any comments below if you would like to see any more practice of things like that. Thank you very much and good day.